Are you getting tired of these scribbles? Well, we've got to keep moving on. We've got to get to the frequency part of all of this stuff. If you haven't watched the previous videos, then this is not even going to make any sense. Even if you've watched them, it might not make sense. But this is where we go. Now, I did some research on this, and because this is this equation here is the uh, in the form of Ks, I think we should put the number of modes in terms of K here and not P. The reference that I used continued to use P here, but I don't like that. So today we're going to use black. Why not use black today? If I can get my selection to that point. Today we're going to use black, and we're going to start by erasing some stuff and putting this in a good form. If I can find okay, here. Got technical difficulties. This is the thing we wanted, vk squared over 2 pi squared dk. So I'm first going to drop this stuff out and start where we left off. And here's the song. It's almost Christmas time, so I need to sing a Christmas song. Jingle bell, jingle bell rock. Okay, let's go with that. This is such a free-form activity that it's obviously not going to get a lot of viewers. Anyway, let me start off up here in black. If I select my pen, that would work a lot better. I'm going to put the number of modes in terms of K, and I'm going to copy what's down there at the bottom, which is V for volume, K squared, and over, ooh, that's messy. Well, I guess I'll leave it. Too bad. 2 pi squared. Boy, my writing today is really off. Anyway, dk, and let's examine that. And I can erase this bottom part because I don't need to copy that anymore. All right, let's examine this. This says for every k, there's a mode that's determined by the volume of the box that we talked about. And because we had those L cubed things there, that's over here, back to this box with the radiation. And for every little tiny change in K, remember K has a wavelength component to it. So we don't want to forget about that. That's going to be really important. And let me fix this K. Boy, that is really sad. That is really sad. Okay, that looks more like a K. That K, now what is that K? Do we remember that? Going back to, if you want to go back to all those videos, you'll find out. But let's put some stuff down here that K is equal to. K is equal to, one thing that we used recently, P pi over L. That was the length of the box. This is the P, which is the kind of like a vector thing, the square root of L squared, M squared, N squared. Whoa, it takes a lot of memory to figure that out. Let's see, what else is it equal to? Well, when we first started this charade, it was equal to 2 pi over the length of a wave. I wrote my lambda backwards. Got dyslexia this morning. Anyway, let's put this. How do you draw a lambda? Okay, let's see. Is that a lambda? That is a mess. Excuse me, folks. It's taken a while here to get myself together. Oh, I know. Here, this is lambda. Oh, okay. That's a very good lambda. Well, compared to some of the stuff I've done. Let's go to equal sign here. And what else is it equal to? Well, I'm going to pull a fast one here and come up here and say that lambda is the wavelength, and that is equal to, whoa, I'm going to throw a fast one. The speed of light. Why the speed of light? Well, these waves are moving at, guess what? The speed of light. And I'm going to put that over the frequency. So if you take the speed of light, divide by the frequency, you'll get the wavelength. For instance, if the wavelength or the frequency was 1 cycle per second, the wavelength would be 186,000 miles. So it's you've got to get up to pretty high frequencies before you get some pretty small wavelengths. And let's see, and light wavelength is like 470 nanometers. So that shows you that frequency is super high. Okay, enough with that nonsense. Okay, what if I replace this lambda with C over F? Well, the F is going to go in the numerator because it's in the denominator here. It switches around. So that's going to be 2 pi F over C. And then dk is going to be equal to not 2 pi F over C, but 2 pi over C df. Now, this is great. Seems great to me. I don't know if it feels great to you, but this F, now we've got something in terms of frequency. If we can plug all this stuff in there to this VK squared, 2 pi squared dk. We're almost there. We're almost there. Let's try this. Now, what I'm going to do is the number of modes. I'm having trouble drawing an N here. But the number of modes in terms of frequency. Number of modes in terms of frequency. So what I'm going to do is walk us through this. The K squared is, well, the V hasn't changed. V is still up there because that determines something about these frequency modes. Remember, that was standing waves created in that box. Here, I'll kind of wiggle over here so you can see I'm talking about the box again. But anyway, the 2 pi, okay, V. Now what we want to do is plug in all this stuff and use this form of K. Now if we plug that in, the V stays there. K squared is going to be 2 pi F over C, and all that's going to be squared. I've got to still hang on to that 2 pi squared down in the denominator. 2 pi squared. And then, let's see, what's the dk? The dk is 2 pi over C df. 2 pi over C df. And here I've got the number of modes in terms of frequency. This is what I wanted. This is where we were headed the whole time. So let's try to not right at an angle here. When you teach, you're supposed to keep things straight on the board because it bothers the students. So anyway, let me see if I can come up with our final great thing on this Christmas Eve. Canceling all this stuff out, we're going to get the 2 pi's. Oh, let's see. That's going to be in the numerator. There's going to be 8 pi squared. Should I do this in 2 steps? Maybe I better. In the numerator, there's going to be 8 pi cubed. 2 times 2 times 2 x pi squared and f squared. And let's see what's in the bottom. I've still got the 2 pi squared. And then what do I have? Let's see, f squared. Okay, did I account for everything? 8 pi cubed f squared. Oh, I still need to keep my df on there. And a whopping c cubed. Boy, that's a huge number. All right, ran out of space as usual. So what I'm going to do is erase. Let's see. Let's leave the K stuff up there. Let's erase. Oh, that was smart. Someday I'll invest in a better drawing setup, but up till now, this is all I've got. Go back to the black, and I'm going to have to erase some more. Sorry, folks. You just have to back up the video to see some of those earlier steps. And of course, my witty commentary that comes along with it. Okay, here's my marker. So N F equals, let's see, did I simplify it yet? No, that's what I needed to do. Here, my train of thought is getting derailed easily. Let's see, what cancels out here? We've got a 4 left in the numerator because the 2 and the 8 canceled out. We've got a pi in the numerator. We still have an f squared, nothing canceled out there. We've got a df. And let's see, what's left in the denominator? C cubed. Da, 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 da. We finally got where we wanted. I know this is what I wanted to do. I don't know if you realize what was happening. Now, I think I can erase all this stuff if I know how to do my pad here. So this is where we can start next time. And you noticed I said next time because your attention span is probably shot by now. So if let's kind of clean stuff up a little bit. So this is where we're going to start. So this puts everything in terms of frequencies. And what were we trying to do with the box anyway? Well, we were having electromagnetic waves in the box, And we were trying to measure the output of those things with a spectrograph. And there was a little hole in the side of the box, and those waves just kind of burn some time up here. Those waves are coming in, they're all different lengths, and they're spinning out here in the out there, and then I've got a detector. That looks like a heart. Uh, a detector, whatever you want to call it. We can still draw something there. Let's say it's a square thing, and I'll label that as a detector so we'll know what we're talking about the next time. This will tell us something about the frequencies that are going to come out, but the key is which ones are going to be stronger? What's the distribution? And guess what? We want to find out what it's done with, depending on the temperature of this. That's the whole goal, is to find out with different temperatures what kind of electromagnetic spectrum do we see. And that's about it for now. So I'm going to stop sharing. And unfortunately, there's going to be another part to this.